This is the real Tom Rose, and this is a really interesting geometry problem. My first reaction to this was oh, that's unsolvable. And the reason why I felt like it was unsolvable was because there was nothing fixing the location of point A. Right? So you realize if you read the wording of this problem that point A could be here or here. And essentially what they're saying is that, what that implies is that regardless of where point A is, the answer comes out the same, which is true. And that's wild. But so anyway, don't worry about the fact that A is not fixed. The answer is going to work. It's going to work no matter what. So let's walk through how to do it. So it's a ridiculous setup. It's as a circle with an inscribed triangle. BD is tangent to the circle. And it says the measure of CBD, which is marked here, is 70. What's the measure of BAC? So I'll put this, I like to draw what I'm looking for on the chart. So we've got a figure here. I'm drawing the angle BAC. That's what I'm hunting for. Now, this is not, one of the things that's tricky about this problem is the thing they've asked for and the tool they give you, those are not drawn on here. So it says the, and this is something you should know anyway. So it's nice that they gave you this, but otherwise you really should have this memorized anyway, which is that the measure of an inscribed angle is equal to half the measure of an inscribed arc. So let's draw on the inscribed arc. Right, so here is the angle BAC has half the measure of the triangle of the angle COB, which I just drew on here. COB happens to be a right angle with this tangent line BD, right? Which means it's also a right angle up here. I'll draw those both in. Now, we know part of this angle. We'd love to know this angle right here. This is an isosceles triangle. All arcs are made of isosceles triangles. Right, we're just drawing two lines from the origin and then connecting them. So those will always be isosceles. So we'd love to know that the angle of that blue angle, because that would give us, we could use that to figure out the measure of the arc. Once you have the measure of the arc, you divide by 2, and then you've got your inscribed angle, right? So you can use the fact that, so this is a right angle here with the tangent line. 70 degrees of it is already used up. They tell you that. So what's left over? 20. So you can't, not enough room, but this must be 20 degrees, right? Because the 20 plus the 70 must equal the 90 that's made by this right angle right at point B. So that is 20 degrees. So for this triangle COB, right, we know that this angle is also 20 because they're isosceles, which means we can calculate the angle at O here, which, because we know the sum of angles equals 180. So we know 20 plus 20, let's call this angle O. That's a bad name. Let's call it X. 20 plus 20 plus X equals 180. Therefore, X must equal 140. If X is 140 and A is half of that, this is the rule they give you, that angle CAB is equal to 1/2 of angle COB. COB is X. So measure of angle CAB is equal to 1/2 of 140, which is equal to 70, which looks about right if you just eyeball it. So that's good. It's a good double check.